And in order to estimate this beta, there are number of approaches that are followed. You have method of moments, you have maximum likelihood method, and then you have ordinary least square method, also popularly known as OLS. In most of the cases in which some other estimation method is found to be preferable, even in those cases, least squares remain remain one of the most important method. And that's why we'll discuss this method, and we'll also discuss method of maximum likelihood, because that is one of the method which is easier to understand. However, it is not being taught. The reason I don't know. So we'll start with estimation process or estimation procedure of these classical linear regression model via least square method. And if you look at the term least squares, there has to be a common understanding that it somehow talks about minimizing something, least, minimum of all the available, variables or all the available calculation. That's why it is based on least. And square is one of the property that comes really natural to human beings. You can find various examples where we proceed with underlying a theory specifying a square relationship amongst variables. We'll understand what this least square principally means and how this process goes ahead. So अभी हमने क्या देखा था कि हमारे पास ये population regression function है, which is written as y is equal to x beta plus mu. We do not know anything about this beta, so we proceed to estimate these population parameters, and then we test the hypothesis whether the estimated beta or estimated sample parameters come from the same population of coefficient parameters. That's what hypothesis testing is all about as far as econometrics is concerned. And that's where we test whether, population parameter is insignificant or it lies or it has certain range. There are a combination of these hypothesis testing that we'll discuss, but ultimately the idea is that whatever best estimate of population parameter you have got, you have to test on that whether it has come from the same population underlying these population parameters. Okay, all right. So this is our population regression function. And since we do not know anything about our population regression function, we try to guess about it. And that's where algebra of least square comes into picture. So what we say is that since we do not know our population regression function, let me write it here. We replace this population regression function by what is called as sample parameters. So after this, whatever we discuss, they all are properties related to sample. और जितना भी हमने assumption पढ़ा अभी CLRM का, they all are related to population. And ultimately, if we knew the entire population, there is no need to talk about, sampling and estimating. And precisely since we do not know the entire population, we undertake the process of sampling, and then we try to, we try to generalize the information that we obtain from a sample, assuming that this sample comes from the same population. And that's where the process of estimation in econometrics is all about. So we don't know anything about this beta. So what we do is we replace this beta by sample parameters, and let me write it as small b. Similarly, this error of population we do not know. Then again, we estimate the error of population by, you can write any letter, but let us write a common terminology denoted by E, which reflects or which tells you the residuals. So errors or estimate of errors of population in sample, they are called as residuals. This beta is for the population parameter or counterpart of population parameter in sample. And your data matrix remains same, so I write it like this: plus E is equal to Y. And then we can simply write this vector of residuals E as y minus x times b. Now, what is the principle of least square? What does least square do? Least square का क्या कहना है? You see, you know y, you know x. What you don't know or what you have or what you're trying to estimate is this b. And since we are talking about least, it means we are trying to talk about minimizing what some square or square of certain variable. So the method of least square runs on the principle of choosing such values of b which minimize the residual sum of squares. Residual sum of squares. So ultimately मेरा कहने का क्या मतलब है कि मुझे ऐसा b और I have to find such b which comes from the population parameter coefficients, and I have to choose this b in such a manner that the residual sum of squares e is minimum. That's why this is called as method of least squares. So ultimately in OLS, what we are trying to do is we are trying to minimize the sum of, or you can say residual sum of squares using or choosing such value of b which makes it possible. So the least square principle is to choose b to minimize the residual sum of squares. And how do we exactly write sum of squares in matrix notation? So what we do is we take that vector containing residuals and we pre-multiply that vector of residuals by its transpose. And you can easily carry out this. So ये E1, E2, मान लो E3 है. Suppose मेरे पास 3 vector of residuals and I want to talk about what? Summation EI square. So E1 square plus E2 square plus E3 square. If you pre-multiply this vector containing residuals by its transpose, ये अगर column vector इसका transpose होगा row vector. So now, you know, first row, first column, first row, so E1 times E1 plus E2 times E2 plus E3 times E2, what you'll find is E1 square plus E2 square plus E3 square. And this is precisely your residual sum of squares. And you know, another way of defining a sum of squares is in terms of the deviation around mean. But since the residuals are assumed to be coming from a population which has a mean value 0, that's why it does not contain that mean term, because anyway mean of these residuals is 0. So what I have to do is I have to minimize this E cross E. Oh, sorry, E transpose E. Now E हमने क्या लिखा था? E,
Sir?
Yeah.
Sir, I don't understand this E transpose E. How is it E square?
If you carry out this multiplication, how will you multiply this vector?
Sir, if E transpose E, it will get cancelled out now.
Which will get cancelled out, dear?
E transpose E.
But why it will get cancelled out?
No, because it is like inverse of it.
Inverse and transpose are two different things, dear.
Yeah, but sir, sir, it will be E square. E transpose into E.
Huh.
It will be E square.
But it is a vector, no. It's a vector, it's not a scalar quantity. X square जो हम normal algebra में लिखते हैं, what is this x square? X multiplied by x, right? But if this was a vector containing, let's say, 3 elements, x1, x2, x3, how do you write in that case square of this vector? I cannot simply write x1 square. It must be, and I'm talking about sum of these squares. So in order to obtain this sum of squares, I pre-multiply this vector by its transpose. Now, if you carry out this multiplication, x1 will get multiplied by x1, x2 will be x2, and x3 will be x3. And then you add them. So it will be x1 square plus x2 square plus x3 square, which is precisely the sum of squares of this vector x1, x2, x3.
Yes, sir, got it. Thank you.
Samjh
Yes,
So
sir.
E transpose E is exact, it gives you exactly your residual sum of squares of residuals, sum of squares. So E1 square, E2 square, E3 square, these are squares of residuals. And what we are trying to obtain? We are trying to obtain the sum of these squared residuals. So E1 square plus E2 square plus E3 square. And if it contains n number of elements as residual vector, you will have n number of square terms. So ultimately मुझे क्या करना है? इस residual sum of squares को minimize करना है. So let us see how do we write this E transpose E. So we just notice that E, that is your residuals, is written as y minus xb. And I pre-multiply this y minus xb by its transpose. So the normal vector multiplication will be here, will be in operation here. So y minus xb ka transpose multiplied by y minus xb. Y minus xb ka transpose will give me y transpose as the first element. This y transpose will get multiplied by y transpose multiplied by xb. Then xb, here I have xb transpose, and if you actually notice, AB ka transpose is nothing but B transpose A transpose. So XB ka transpose will be B transpose X transpose. Am I clear? So it will be your Y transpose Y minus Y transpose XB minus of B transpose X transpose Y plus B transpose X transpose XB. Is this clear, everyone? Is this multiplication part clear to all of you?
Yes, sir.
Okay. अब आप देखिए, just look at this middle term. It is Y transpose XB minus B transpose X transpose Y. Now, if you actually notice, this Y transpose XB is nothing but, and if you take transpose of this, that is, if I take transpose of Y transpose XB, it will be, now again, if I take it A times B, so B transpose A transpose, iska transpose will be B transpose X transpose, and Y transpose ka transpose will be Y. So if you actually notice, Y transpose XB ka transpose is exactly this term. And if you actually see XB, if I say that, I have a data matrix, X ka dimension hai n times K, and B ka dimension hai K times 1. So this multiplication ka dimension will be n times 1. And I'm multiplying this by Y transpose. Y kya hai mera? Y is a vector consisting of n number of elements of dependent variables. So it has a dimension n times 1. If I take it transpose, it becomes a row vector. So now Y transpose ka dimension becomes 1 times n. And if you see Y transpose XB, multiplication of vector will require this dimension. So actually what you notice is this Y transpose XB is actually a scalar quantity, because the dimension is 1 times 1. It's a scalar, it's not a vector. So a property of a transpose of vector is that if you take transpose of a scalar quantity, the transpose is equal to that scalar quantity. So Y transpose XB is a scalar quantity. If I take transpose, so Y transpose XB is exactly equal to B transpose X transpose Y. So I can replace this Y transpose XB in this equation by B transpose X transpose Y. And if you solve this algebra, what you'll notice is that the middle term can exactly be written as Am I clear here? Everyone?
Yes, sir.
Nahi aaya to I'll repeat this point again, but just let me know if you're clear with this. Are we all clear that how Y transpose XB is written exactly as B transpose X transpose Y?
Yes, sir.
Okay, so shall I move ahead?
Yes, sir.
Okay, so अब मेरा क्या है, अब जैसे नॉर्मल मिनिमाइजेशन प्रोसेस फॉलो करते हैं, मेरा एक इक्वेशन आ गया रेसिडुअल सम ऑफ स्क्वायर्स का, एंड दिस रेसिडुअल सम ऑफ स्क्वायर्स कंटेन दिस बी टर्म. And you understand this ultimately B is a coefficient vector, so whether it's transpose or is written in column vector, it should not matter a lot. So this E transpose E term contains these B terms, and ultimately what I have to do, I have to minimize this residual sum of squares. So somewhat I'm talking about del of RSS with respect to del of B, right? Am I clear? अगर ये normal equation था y is equal to x square plus 2x, and if I had asked you to find the minimum point of y with respect to x, you would have taken the first order differentiation del y upon del x and equate it to 0, right? This is the normal process of finding maxima or minima of functions. Am I clear, guys?
Yes, sir.
Okay. So अभी मुझे क्या करना है इसको, मुझे इस residual sum of squares को with respect to b I have to minimize. It means I have to find out the first order differentiation, which is a matrix differentiation over here. This is not a normal algebra. So, and matrix differentiation again follows the same process, because ultimately a vector is what? Vector consisting of n number of elements, or अगर मुझे उसे differentiate करना, it means I'll differentiate each of those n number of elements with respect to the differentiating variable. It means I have to differentiate this whole function with respect to b and equate that to 0. That will give me the condition, or that will give me the condition for the minimization of this residual sum of squares. Now let us understand how do we exactly go around differentiation of matrix which involves like this. So just look at the first term. This term does not contain any b part, so this will automatically go to 0. Just focus on this term over here. I have 2b transpose x transpose y. So this looks to me a linear function. If I just imagine this x transpose y as I replace this by a. So this becomes do b transpose a, and if I have to differentiate this whole equation or whole term with respect to b, assuming this a remains same, how do I differentiate this? So if you actually see, this term involves you can say, or this term is linear in B, linear in the coefficient parameter. Because this x transpose y is a k element column vector of known numbers. This is known to me, x transpose y. Because x is your data matrix, y is also the data that you've collected on the dependent variable. So ultimately this product x transpose y is known to you. This does not behave as variable. What is variable over here is this b term. So this second term in this equation is linear in B, and this x transpose y is a k element column vector of known numbers. So now to differentiate a linear function in matrix notation, let me write this whole equation in terms of B. So if I write this as f of B, I can either write this as A transpose B or B transpose A. It should not matter to me as long as I have this vector of known variables. So A transpose B means what? B is a column vector, A is a row vector. B transpose A is what? B is a row vector, A is a column vector. And if you just carry out this multiplication process, it will look to you A1 B1 plus A2 B2, so on, AN BN. And if you just, and it is exactly equal to your B transpose A as well. So it does not matter to us as far as the term is linear in nature, whether you write as A transpose B or B transpose A, the multiplication remains the same. Now, what it means is that since this term is written in the form of B transpose A, this is also equal to x transpose y ka transpose multiplied by b. That's what this term, this equality tells you over here. Because these a's, x transpose y in this case, are given constants. They are not variable. So if I have to differentiate this whole term, I'll differentiate each of the term with respect to b. So ultimately what we're trying to do is we are trying to calculate the partial derivatives of this column vector. Either I can arrange this as a column vector or as a row vector, it should not matter to me. So if I have to write del of FB, del of FB with respect to B, what I'm saying here is either I can have del of A transpose B with respect to B or del of B transpose A with respect to B. It shouldn't matter to me because A is anyway a given constant. So if you differentiate this B transpose A and arrange those partial differentiation in a column vector, because ultimately we are representing all of them in a column vector, that's why I'm arranging them in the same manner, otherwise it does not change any analysis. So if I differentiate this whole term, B transpose A is nothing but A1 B1 plus A2 B2 plus A3 B3 till AN Bn, assuming that there are n number of elements. So if I differentiate this first term with respect to B1, it gives me A1. This term with respect to B2, this gives me A2. And so on till nth term, this will give me an. So what I notice is that partial differentiation of this linear term containing B, if I arrange those partial different derivatives in a column vector, I can think of writing them as A1, A2, so on till an. And ultimately, this is a column vector consisting of those elements of known variables. So just let me write it as A. Now, if you just replace this A by X transpose Y, so what you notice is that differentiation of this second element with respect to B just gives you X transpose Y. And then, 2 is obviously multiplied over here. So the differentiation of this term will be 2 times X transpose Y. Now, moving ahead, if you see the third term, this term, अगर आपको symmetric matrices, quadratic form of matrices, अगर आपको याद है थोड़ा बहुत जो हमने discuss किया था, so if you actually notice this third term, what this third term is, this third term is generally a quadratic form in B, because if you notice this B transpose XB, now notice that this X transpose X will be a symmetric matrix, it will be a square matrix in the first place, and I also am saying that for the time that it will also be a symmetric matrix, because ultimately they are, X transpose X क्या है आपका, अगर आपका मान लीजिए X है 1 1 X1 X2, X transpose अगर आप इसका लोगे, so it will become 1 1 X1 X2. Now pre-multiply this X transpose with X, what you get here is 1 1 X1 X2. So what you'll notice is that the elements across these principal diagonal will be equal to each other, because ultimately they are nothing but the square of the same vector, and this is the column vector consisting of 1, so it does not change anything. So if you actually notice, this B transpose XB is actually a symmetric or a quadratic form in B. So I can write this whole thing as f of B as, I can write this as B transpose A times B. And this A here is X transpose X. So this tells you that this A is a symmetric matrix over here, and this symmetric matrix is pre-multiplied by a row vector and post-multiplied by a column vector consisting of those sample estimates. And actually, if you just open this B transpose AB, so let me write this as f of B as B transpose kya hoga? Let us just, for the sake of simplicity, assume that there are only three explanative variables included in the model, including the constant. So B1, B2, B3. A is what? A is my symmetric matrix. So I'll just write in the coefficient terms, whatever it is, A11, A12, A13, A21, A22, A23, A31, A32, A33. And this getting post multiplied by the column vector consisting of those coefficients, so I can write it as. Now if you multiply this whole term, what you'll notice is that you'll have, you see A11 get multiplied by B1 and then again it gets multiplied by B1. So what you'll notice that you'll have B1 square terms, B2 square term, B3 square term. Then you'll have also an interaction between B1, B2, B1, B3, similarly B2, B3 and B3, B1. So what you notice is if you just carry on this multiplication process, what you'll get is that A11 B1 square plus A22B2 square plus A33B3 square. Then I'll have the interaction term between these coefficients. So you'll have twice of A12B1B2 plus twice of A13B1B3 and finally twice of A23B2B3. So this is the term which is a quadratic form in B. When I expand this term, that is the third term in the residual sum of square equation, I get this as my multiplic, or you can say expanded form of the equation of the term that we get. Now what I have to do, since I know that this is a quadratic form in B, I'll take this del of f of b and I'll differentiate this with respect to b. Because ultimately I'm choosing, or the variable here in my case is this b. I have to choose such value of b which minimizes this term, or which gives me, or I have to calculate the partial derivative of this whole expression with respect to b. So what you notice this is, ultimately what I'm trying to talk about is the del of f upon del b1, del of f upon del b2 and del of f upon del b3. Ultimately I'm trying to talk about partial derivative of this whole function with respect to b1, with respect to b2, with respect to b3, because ultimately b itself is a vector. And this vector consists of three elements. So if I'm trying to talk about the partial derivative of this whole vector or whole term, I'll differentiate each of those terms with respect to b1, b2, b3. So if you take the first order partial derivative of this whole expression with respect to b1, what you notice is that यहाँ पे मेरे पास एक b1 term है, sorry, यहाँ पे मेरे पास एक b1 term है, यहाँ पे मेरे पास एक b1 term है. And if you differentiate this, so what I'll get from here is twice of a11 b1. यहाँ से क्या मिलेगा आपको? यहाँ से मिलेगा twice of a12 b2. एंड यहां से मिलेगा आपको ट्वाइस ऑफ a13b3. ठीक है? एंड इफ यू टेक टू कॉमन, I can write this whole expression as twice of a11b1 plus a12b2 plus a13b3. And I'm arranging these partial derivative in the form of column vector just to maintain that similar notation. Otherwise, you can arrange them in a row vector; it does not change at all or anything. Similarly, if I take the partial derivative of this whole term with respect to b2, what I'll get is I have b2 term over here, I have b2 term over here, and I have b2 term over here. So what you notice is, and सब में आपको 2 मिलेगा common, so I can write this as a22 b2 प्लस यहां से आपको एक टर्म मिलेगा a12 b1 और यहां से आपको एक टर्म मिलेगा a23 b3. And by the same analogy, what you'll get is twice of a33 b3 plus a13 b1 plus a23 b2. And if you actually notice this a11 b1, a12 b2, a13 b3, a22 b2, a12 b1, अगर आप इसको थोड़ा अरेंज कर दो, a22 टर्म को यहाँ लिखो, a33 टर्म को यहाँ लिखो, so this is the same symmetric matrix a times b. That is what I'm talking about here is this multiplied by this is nothing but this term. So the partial derivative or partial differentiation of the third term in residual sum of squares gives me the whole expression as twice of a times b, where this a is, if you remember, x transpose x. So the third term in the residual sum of squares that we had written over here, this gives you the differentiated vector as twice of x transpose x b. This gives you twice of x transpose y. So ultimately, del of RSS with respect to del of b, what I get here is minus of twice of x transpose y plus of twice of x transpose x times b, and I'll equate this first order differentiation equal to 0. So what you get here over is twice of X transpose XB equal to twice of X transpose Y cancel out each other. So you get X transpose XB equal to X transpose Y.
Sir, I didn't understand from after we found df upon d b3.
कहाँ पे ये वाला?
Yeah, sir. How did we got this 2ab equation?
You see, ये क्या है term dear आपका? A11 times B1, A12 times B2 plus A13 times B3. If you just focus on this part, this is my A, this is my B. Multiplication of this matrix with the vector is A11 times B1 plus A12 first row, first column. So A11 times B1 plus A12 times B2 plus A13 times B3, which is exactly this term. Second row, first column, A21 times B1, A22 times B2. So आपको क्या मिलेगा? ये जो तीनों, ये जो vector में जो मिला है consisting of 3 number of elements, this is nothing but A times B with a scalar multiplied by 2. So it is twice of AB. Is this clear?
Yes, sir.
हाँ जी. So this notation that we have got after we differentiated RSS with respect to B, that is, let me write the RSS over here. My residual sum of squares was Y transpose Y minus of 2B transpose X transpose Y plus of B transpose X transpose times B. When I took partial differentiation of this RSS with respect to B, which itself is a vector, please don't understand it's a scalar quantity. That's why I'm differentiating with respect to all the B, B1, B2, B3. Just example taking that only 3 exponential variables are there. If you have n number of exponential variables, you'll have n number of such terms. So this partial differentiation gives me the point twice of X transpose Y plus twice of X transpose X times B equated to 0. What you get from here is X transpose X times B equals to X transpose Y. Guys, this is nothing but your normal equations. And now why matrices method is so easy to visualize is because ultimately you do not need to remember any of the normal equations that you otherwise ratify from Gujarati's basic econometrics textbook. But because once you understand this, this is nothing but in the form of matrix multiplication. X transpose X, this is known to you. Because this is nothing but a data matrix. X transpose Y, this is known to you. Only thing that is not known to you is your B term. So it means this normal equation will also give me a solution for this coefficient vector B. अब ये B को मैं कैसे निकालूंगा? ये तो matrix method है, इसमें generally मैं और matrices में I cannot have division. So in order to remove this or X transpose X from the left hand side, what I do is I pre-multiply both the sides of the expression by X transpose X ka inverse. So A inverse A is your identity matrix. That is the property that I'll use. So if you pre-multiply both the sides by X transpose X inverse, what will happen is X transpose X inverse multiplied by X transpose XB equal to X transpose X inverse multiplied by X transpose Y. Now this term X transpose X inverse multiplied by X transpose X, this will be identity matrix. So let me just write it here. So this is the solution that you get for B. Now if you remember, someone was asking that why it is called an identification assumption, that is assumption number 2. Because you cannot have inverse of this X transpose X if X does not contain full column rank. Inverse of a matrix के लिए आपका जो determinant है, that should be non-zero, the highest order determinant. And precisely the assumption of full column rank for the data matrix ensures that the data matrix has full order determinant being non-zero. So in order to obtain the solution of B using the OLS method or in this linear regression method, not just OLS, I want my data matrix having full column rank. That is, none of the explanatory variables should be exactly correlated or perfectly correlated with any of the other explanatory variables included in the model. So अभी हमने दो चीज देखा. This is called your normal equation. This is your solution for B. So this is nothing but your, this is how you find your B1, B2, B3, B4, B5, and so on till Bk. Just take a simple example and just try to draw an analogy why, how normal equations are so easy to interpret once you understand them in this fashion. So let me say that, there are the data matrix that I have, it's a bivariate model. Bivariate model means I have only one explanative variables and other explanative variable is the intercept term. So the data matrix looks to me somewhere like, so n number of observations on the first intercept term. So I have a column vector consisting of n number of ones. Then I have x1, x2, so on till xn. That is, I have only single explanative variable given by x. So this is my data matrix. अब मुझे क्या चाहिए यहाँ पे x ट्रांसपोज x चाहिए. So what I'll do is I'll take x transpose. So x transpose क्या होगा इसका? This is the column vector. इसका ट्रांसपोज करोगे तो this will become row. Column vector transpose it will become row. So now if you take x transpose x, what is happening over here is 1, 1, 1, x1, xn. So what you notice here is first row multiplied by first column, 1 into 1 plus 1 into 1 plus 1 into 1 plus 1 into 1, so on till nth term. It means the first term on this multiplied matrix will be n. First row multiplied by second column, x1 times 1 plus x2 times 1 plus x3 times 1, so on till xn times 1. That is x1 plus x2 plus x3 plus x4, so on till xn. It means this is nothing but summation x. And since this, I told you this x transpose x is a symmetric matrix, it means जो element यहाँ पे होगा, that is first row second column, वही element second row first column में होना चाहिए. It means this term will also be summation x, and you can easily verify it. Second row first column, x1 times x1 plus x2 times x1, so on till xn times x1, xn times 1. So it will be summation x, and now the last, that is second row second column, will give me x1 square plus x2 square plus x3 square, so on till xn square. So I can easily write it as summation x square. So this is the term which is x transpose x. Now what do I need? In order to talk about this normal equation, I need x transpose y. So x transpose मुझे easily पता है. X transpose is 1, 1, 1, x1 till xn. I have to multiply this x transpose with column vector consisting of n number of observations on the dependent variable. So it will be y1, yn. Now if you take this multiplication, first row, first column, it will be y1 times y1 plus y2 times 1 plus y3 times 1, so on till yn times 1. It means the first term of this multiplied matrix will be summation y. Second term will be x1 times y1, x2 times y1, y2, x3 times y3, x4 times y4, so on till xn times yn. It means the second element will be summation xy. So now if you write this whole expression, I'll have n summation x square multiplied by b1 b2 is equal to summation y summation xy. And if you just expand this, so what you'll get here is n times b1 plus b2 times summation x is summation y, and similarly b1 times summation x plus b2 times summation x square is your summation xy. And these are precisely the normal equations that you see for bivariate model. Am I clear here?
Sir, can you wait for 2 minutes?
Yeah.
And scroll up.
Take your time.
Excuse me, sir.
हाँ जी.
So if we are using the word summation,
हाँ
so
जी.
shouldn't we write summation x the instead of simple summation x?
Come again, summation?
Summation xi,
But
like the
why?
subscription x.
I did not write subscript there because there is only single explanative variable. Obviously, you're right. Summation xi y होना चाहिए, but I just omitted the subscript. Nothing else. So summation xy तुम्हें समझ में आना चाहिए कि x1 y1 plus x2 y2 plus x and y in वाला term है. Because this is how we derive this here. No? I just omitted the subscript. Nothing else.
No, we are just proving the B wala equation, right?
Come again.
Right. We are just proving the equation x transpose x into B is equal to x transpose y,
Yeah,
right?
yeah. I just expanded the normal equation. So
Yeah.
if you
Okay, sir. Got it.
yeah. So अगर आप देखोगे basic econometrics textbook में this is how they and once this goes from bivariate to multivariate, it is extremely difficult to keep track of the normal equation. But you have to simply understand this term. X transpose xv must be equal to x transpose y. This is the fundamental equation of the least square, and it is called as normal equation. Now on the same basis, जैसे आपने ये equation लिखा है यहाँ पे, I request you to write normal equations for 3 variable equation. That is, you have 2 explanatory variables and 1 intercept. Just try, everyone. Just write normal equations using this notation x transpose x times b is equal to x transpose y for a 3 variable equation. Can you do that? And take 5 minutes for that. So I'll exactly ask you at 12:27. Please do that. Okay, all right. Are you done with that?
Just a minute, sir.
Okay.
Yes, sir, you can go on.
Okay. Everyone, are you done with this?
Yes, sir.
Are you able to do it?
Yes, sir.
And now, do you find it easier to understand the normal equations? You do not need to remember them.
Yes, sir.
ठीक है? Shall I move ahead?
Yes, sir.
Okay. So, having understood this normal equation, let me write the expression over here. Expression is x transpose b equals to x transpose y. और यहीं से आपका b is what? B is your estimate of the population parameter. So, and ultimately we are interested in finding out this b only. And the method that we used in order to find this b is called the principle of least squares. And the idea was what? I express the equation first in the form of residuals. Residuals is what? Residuals is the actual observation minus the fitted observation. अगर आप actually देखो y is equal to xb plus e, हमने उस दिन क्या देखा था? There was an assumption of exogeneity of endogenous variable which makes expected value of u conditional on x equal to 0. So this xb term is the fitted values of the population or linear combination of x's, and since I have replaced those population parameter by b, it means this will be the fitted values of the regression in the sample. So, and how do I write E? E is y minus xb. It means this residual this is the actual observation and this is the fitted values of the sample using the regression. So residual is difference of actual observation on y, because ultimately xb is what? xb is that component of y which lies inside the plane spanned by the explanatory vectors. So the difference between the fitted value, this is called the fitted values. Fitted values means what? आपके पास जो data matrix था, आपने उसको b उस वैसे b से multiply किया जो आपका best possible fit दे रहा है data को. And then you take the difference between the actual observation, actual y's, which lies outside the plane, and the fitted values. They are nothing but called residuals. So ultimately मेरा motive क्या है? My motive is to minimize this residual term. Now, why I just do not minimize this residual term as it is? Because it might be the case that, if I take summation of E, it might be the case that it might also go to 0. So one possible reason could have been I could have taken summation of mod E and equate it to 0. But then again, taking mod becomes really difficult once you have more than, or once you have enough number of observations. So what we simply do is we square those residual term and then take the sum of those squared and we simply minimize that sum of squared residuals. Because squaring anyway what it does is, if you just simply take mod, squaring क्या करता है? Squaring takes care of each of the observation deviations. We will simply square it. Take the sum, minimize that sum of squares with respect to the b, because that is the only variable along which you are trying to minimize the line or minimize the error term. So once you follow this process, you write this E, or in matrix notation you write this as E transpose E. Simply take the differentiation, equate it to 0, and this is the term that you get. So this is called a normal equation, and if once we pre-multiply both the sides of the expression by x transpose x inverse, what we get is a solution vector for B, which is written as x transpose x inverse x transpose y. So I do not need to remember anything. All I need to take care of is how do I exactly write my expression for this, or how do I expand this expression. Once you are done with this, you know x transpose x, you know x transpose y, just use certain techniques to solve for B and you'll get the solution. Now one thing you notice that in this normal equation, if I replace this y by xb plus e, because y is nothing but xb plus e, then you expand this right hand side, it will become x transpose xb plus x transpose e. Here you have x transpose xb. This term cancel out. So what you get is x transpose e is equal to 0. And this is precisely the assumption that we had for the population. Assumption of endogeneity of endogenous variables. Sorry, exogeneity of endogenous variables. What that says is that no such observation in the data matrix convey any information whatsoever on the conditional average value of the error term. And this we get for the sample counterpart using OLS. So we do not need to assume this for the sample counterpart of the residuals, because this automatically guarantees me that x transpose e is equal to 0. It means the data matrix is uncorrelated with the residual term of the equation of the model, and this we had assumed for the population error term to hold when we are discussing the third assumption in CLRM. So if you actually notice this x transpose e equal to 0, ये इसका बहुत algebraic property है. अगर आप मैं simple x transpose को लेता हूँ, x transpose normal जो मेरा x है, अगर 1 1 x1 x2 है ऐसे, x transpose का पहला term जो होगा, पहला row जो होगा वो 1 1 होगा. So this, I'm just ignoring the second term, multiplied by e. Let's say e1 e2. I'm just taking the first term. So E1 plus E2 plus E1 times E1 plus E2 times 1 equals 0 means so this automatically guarantees that sum of residuals in the sample regression function is 0 as long as you have an intercept term present in the model. And rest of the time you can easily verify it will be E1 times x1 plus E2 times x2 and so on and so forth is equal to 0, means none of the term are correlated with each other or correlated with the residuals. But understand this part, why you always prefer to use a linear regression model using intercept or constant term is because it necessarily guarantees that the sum of the residuals in the sample regression function is going to be 0. So what it means over here is that summation EI going to 0 means I can write this in the mean form. So I can write this as E bar, just denoting the average value of error term. And I can easily write it as Y bar minus B1 minus B2 x2 bar minus B3 x3 bar, so on till minus BK xk bar. Why I'm writing this like this? It comes directly from here, Y minus xb. And I'm taking average value from both the sides. So E bar is equal to Y bar minus x1 b1 bar, x2 b2 bar, and b1 minus b2 x2 bar minus b3 x3 bar, and so on so forth till kth exponential wave. Well, and this must be equal to 0. this is a very important implication. What it says is that the residuals have zero mean, okay? But you notice this is the exact regression plane, because we are talking about more than one variable, excluding constant. So this represents to me a plane, a regression hyperplane, and this passes through x2 bar, x3 bar, so on till xk bar. What it says is that the regression plane passes through the point of means of the observations. And this is one of the statistical properties of OLS estimators. That if you have an intercept term present in the equation, it necessarily guarantees two things. It guarantees that your sum of residuals is zero, and in turn, the average value of residuals turn out to be zero, and which implies that the regression plane passes through the means of the observation, because here y bar is what? Mean of all the observations on the dependent variable. x1 bar is what? Mean of observations on the first explanatory variables. And so on till xk bar. It means regression plane passes through the point of means of the observations. Am I clear here?
Sir,
हाँ जी.
sir, ये why we are taking this average वाला part थोड़ा समझाइए sir.
Why are we taking this average? That's what you're asking?
Yes sir.
See, this x transpose E equal to 0 gives me summation EI equal to 0. Summation EI अगर 0 हो गया तो average value will also be 0 because divided by n will be 0. So I write it as E bar. E क्या है मेरा? E है y minus xb. This is the matrix form. So y minus x1 beta, y minus let's say first term is constant beta 1 minus beta 2 x2 minus b3 x3 minus b4 x4 to, so on till bk xk. For one second. हेलो अच्छा हाँ सर, मैं चेक करता हूँ लेक्चर में, उसके बाद मैं कर देता हूँ उसको. सर सेमेस्टर एंड मैं कल तक दे पाऊंगा. अभी मैं आई एम जस्ट चेकिंग, बहुत पेपर्स है सर, तो मैं धीरे धीरे चेक कर रहा हूँ. तो आई थिंक कल नहीं तो परसों तक तो मैक्सिमम दे दूंगा आपको. ठीक है सर, ठीक है. बट हाँ भाई पेपर्स है ना सर, एक्चुअली बहुत है, तो मैं कर दूंगा. लाइक मैक्सिमम आई ट्राई टुमारो ही हो जाए, बट अगर नहीं होता तो आपको एंड ऑफ डे मिल जाएगा. हाँ ओके. Okay, sorry. So what I was talking here is that E bar means what? अब मैं सारे both the sides में मैंने average value लिया है. So y का average will be y bar, x1 का average will be x1 bar, x2 का average will be x2 bar, and so on so forth. I can take till xk. So I'm able to write this expression over here. And this whole term going to 0 means what? अब जैसे हम जब हमारे पास स्ट्रेट लाइन होता है, we simply write y is equal to mx plus c. But जब मेरे पास more than one dimension की बात आती है, I simply write it as ax plus by plus c times z is equal to 0. This is the equation of a line in a plane. Similarly, if you understand this term over here, this is y bar minus this term whole going to 0. It means जो मेरा regression line है, sample regression line है, because it includes this beta 1 beta 2.
इंटरसेप्ट टर्म छोड़ गया.
करेक्ट. सो जो वो लाइन है वो पास करता है मीन पॉइंट से. एंड दिस इट मींस व्हाट इट सेज इज कि अगर जस्ट टेकिंग वन एग्जांपल, अगर ये मेरा x है, ये मेरा y है, और इसका x बार y बार, if this is the point, let's say if this is x bar and this is y bar, this is the point, what it says is your sample regression line definitely has to pass through this. Am I clear?
Yes sir. Thank you.
Okay. अब यहां तक तो बात समझ में आती है कि these are the some of the algebraic properties of OLS estimators. One more thing that we have to understand over here is, before we move ahead, one second. So, once we have understood this point, I'll not take any algebra forward from this point. I'll just try to give you an intuitive understanding कि exactly हम ये कर क्या रहे हैं, कैसे इसको हम visualize कर सकते हैं geometrical interpretation के through. Just focus on this part. Very simple. So अभी तक हमने क्या देखा? Let me just write all this again. अभी तक हमने देखा कि हमारा जो B है, that is OLS estimators, it can be written in this form. And we understood that this I get by minimizing the sum of squared residuals. But just take a step back and try and understand what exactly are we doing over here. Why are we doing this? कुछ तो लॉजिक होना चाहिए, और mathematically we have proved this, we have done this, but how do I exactly visualize this part of what we are doing? Just try and understand this part. Suppose मेरा मॉडल है, let me just omit the subscript for the time. ये मेरा मॉडल है. So this is my population regression function. I do not know this beta naught, beta 1, beta 2, so I'll have my sample regression function, which can be written as Am I clear? यहां तक पॉपुलेशन रिग्रेशन फंक्शन, सैंपल रिग्रेशन फंक्शन में गाइस प्लीज कंफ्यूज मत होना, क्योंकि यही पे सारा खेल है. पॉपुलेशन रिग्रेशन फंक्शन को हम अज्यूम करते हैं ऐसा दिखेगा, और इस अजम्पशन पे हम आगे बढ़ते हैं कि जो सैंपल हम कलेक्ट किए वो इस पॉपुलेशन का रिप्रेजेंटेटिव है. एंड दैट्स व्हाई आई एम एबल टू राइट सैंपल रिग्रेशन फंक्शन लाइक दिस. अब मेरा मोटिव क्या है? मेरा मोटिव है कि मुझे ऐसा सैंपल रिग्रेशन फंक्शन और सैंपल रिग्रेशन लाइन चाहिए जो कि मेरे एरर को सबसे मिनिमम वैल्यू दे. एरर क्या है? एरर इज डिफरेंस बिटवीन एक्चुअल ऑब्जर्व्ड वैल्यू एंड फिटेड वैल्यूज फ्रॉम द रिग्रेशन. Now let us understand what exactly do I mean by this. So I have only two explanative variables, x1 and x2. Let me say that this is my x2, this is my x1. ये दो explanative vectors हैं. Just for the sake of simplicity, let us assume that they only contain two number of observations. Just for the sake of simplicity. So they are a column vector consisting of two number of elements, so they are in Euclidean dimension space. Why Euclidean? Because you can exactly measure the Euclidean distance between these two vectors. That's why they are called Euclidean space. क्या है कंडीशन मेरा? मैं इसको y को कैसे लिखा हूं? b0 plus b1 plus b2 x2. Just for the time being, ignore this b0 part. अब मेरा y क्या है? मेरा y है sum of this component and this component. And since ये वेक्टर के फॉर्म में लिखा हुआ है, if you are adding these two vectors like this, it means the angle between these two vectors must be 90 degree. That's why you're simply adding them up. अगर एंगल रहता तो उसके बीच एक cos थीटा का टर्म ऐड हो जाता. And precisely, why we are able to write a plus b ka whole square, a square plus b square plus 2ab. That 2ab term should tell you that precisely there is some angle between A and B. That's why you have that 2AB term. Otherwise, you can simply, use the Pythagoras theorem. You can simply write B square is equal to A square plus C square. And there is no AB term over there. Same thing over here. It definitely tells me that, these two components must be orthogonal to each other. अब इसका मतलब क्या है ये देखते हैं. तो ये मेरा दो एक्सपेंसिव वेक्टर है x1 x2. अब अगर मेरा y इन्हीं दोनों वेक्टर्स के जो जितना वेक्टर स्पैन होगा, बाय वेक्टर स्पैन में आई मीन व्हाट, a suitable linear combination of these two vectors, and spanning of the entire space is nothing but called your vector span. So if y lied inside the vector span of these two explanative variables, then there is no talk about error terms at all, because ultimately y lies in the same plane, and by taking suitable scalar multiplication of both these two vectors, I can reach that point exactly. But y lies outside the plane. That's why you have this error term. So let me say that this is my y. So imagine कीजिए ये x1 x2 का ये वेक्टर स्पैन है और ये y exactly z एक्सिस पे है. So x1 x2 को आप imagine कीजिए ये that whichever room you are sitting in, the floor is the vector, and only let us just for the sake of simplicity let us only assume that the first quadrant is there. So the floor on which you are sitting, all the points on that floor represents the linear combination of these two x1 and x2. तो अगर y उस फ्लोर पे रहेगा कहीं पे भी, as long as the vectors are not co-linear with each other, you can reach that y by having a suitable linear combination of both these two vectors. But precisely y क्या है? Let us just for the sake of visualizing, let us assume that y lies on the ceiling of your room. कोई भी पॉइंट ले सकते हो, जो भी आपका पॉइंट रेफरेंस पॉइंट होगा. लेट अस जस्ट टेक फॉर द रेफरेंस y इज योर फैन जो आपके सीलिंग में लटका हुआ है. अब मेरा क्या है मोटिव? मेरा मोटिव क्या होना चाहिए कि मुझे तो एक्चुअली y तक पहुंचना है जो कि मेरा फैन है. If I had some superpower, I can directly jump onto the ceiling, but I cannot do that. So what I'll do is, I'll try to locate such point in the linear combination of the two vectors. That is, I'll try to locate such point on the floor which gives me the minimum distance from the floor to ceiling. From that point. Otherwise, ceiling and floor are 90 degrees to each other. They are parallel. So, getting to such a point in the floor or on the floor means I have to choose such value of B1 and B2, because ultimately it is this B1 and B2 which gets multiplied by these explanative variables, and then you get the linear combination. So, as you change the values of B1 and B2, you'll reach different points in the space, in the vector span spanned by these two vectors or explanative variables. And this is what you mean by choosing that value of B, or choosing that value of B which fits the line properly or which fits the data. It means by carefully selecting such values of B which takes me exactly to the point on the floor which lies exactly below the point on the ceiling, that is in this case my fan. And once I reach that point, I drop a perpendicular from the fan to the ceiling. That is the error of the model. Because that is the part which I am not able to explain by using the explanatory variables. Only part which I am able to explain by using the explanatory variables is the linear combination part. So the perpendicular distance from the actual y to fitted value is nothing but your error term. Now let us try and understand this. So x1, x2, अगर इसका मैं linear combination, let me say that this is the linear combination of x1 and x2, and let me denote it by y hat, estimated. एक econometrics या statistics में common terminology है कि जहां भी आप estimator को use कर रहे हो वहां आप hat लगा देते हो. तो that's why बहुत सारे book में beta 1 hat, beta 2 hat भी देखोगे. बट अगेन टर्मिनोलॉजी आपको जो पसंद है, जैसे समझ में आता है वैसे यूज कीजिए. So this is my linear combination. So y hat is what? Y hat will be b1 x1 plus b2 x2. It means I have reached, and if I'm assuming that this b1 b2 is that one value of b1 and b2 which takes me exactly below the point of y. So this is the fitted values of the regression which has been explained by x1 and x2. कि भाई y में जो भी variation है, इतने part of variation I'm able to explain by understanding the movements in x1 and x2. The rest of the variation which I'm not able to explain, I attribute this to the error term. And this is what exactly your motive behind understanding or making these models are. Now what I do, this is my y, this is my fitted values. Just forgive me for this. From this fitted values, I take this vector or I drop a perpendicular. What I notice here is the angle between these two vectors, y hat and this vector, is 90 degree. And it is exactly this vector which is denoted by your residuals. And it is precisely what we are doing.
Sir,
हाँ जी.
so your y hat is supposedly on the floor.
Yeah, it is on the floor.
Okay.
It is on the floor and it is exactly lying just below the point where actual y is situated. Otherwise आप notice करो, I can have n number of linear combination of fitted values. Infinite number as long as x1 and x2 are not perfectly correlated. But is it necessary that suppose this is one of my fitted values, is it necessary that there is, or the error term between the fitted values and the actual observation lies at 90 degree? It is not necessary. And that is why now you must understand that is why these equations are also...
Could you repeat the last thing? It is not necessary that...
It is not necessary that any linear combination will lie at a 90 degree angle with the error of the model.
Sir, then,
Yeah,
then the
what?
distance, sir, it will not be 90 degree, then distance will not be minimum.
Minimum, correct. So, and now you must relate this idea that why these are called normal equations, because exactly of this perpendicular relation between the error term and the fitted values. आप इमेजिन करो ना, जिस रूम में आप बैठे हुए हो, जहां आपका फैन है, उसके एग्जैक्टली पॉइंट पे पहुंचना है, एंड यू टेक एनी पॉइंट, एनी लीनियर कॉम्बिनेशन which lies, which is all the points but this point which lies exactly below. And then if you take the distance between the actual y and the fitted values, it is not necessary that the angle between these two vectors will be 90 degree. And it is precisely that we want, because if I want to minimize the distance between these 2 points, I must have a perpendicular, or I must have an angle of 90 degree between these 2 vectors. And it is precisely what is called as choosing that value of b which minimizes the sum of squares of residuals. Otherwise, if it was the case that any linear combination of y works, altogether a different thing. But precisely is the point that any linear combination of y does not work. Only linear combination of y works which makes the distance between the error term and the fitted values an angle of, or minimum, that is an angle of 90 degree. And precisely this is the reason why they are called as normal equations. और इसी एग्जांपल को आप जनरलाइज करके आप k नंबर ऑफ वेरिएबल्स तक लेके जाओ, दैट इज यहां पे सिर्फ हमने 2 वेक्टर लिया है, यू कैन हैव k नंबर ऑफ एक्सपेरिमेंटल वेरिएबल्स. So ultimately then there you will be talking about Euclidean k-dimension Euclidean space, logic still remains the same. क्योंकि वहां पे error term है, it means y does not lie in the k dimensions vector span spanned by these explanatory variables. And precisely since y lies outside this plane or outside this, linear combination, I want to choose such value of b which takes me to that point which lies exactly below the actual y on the linear combination of the vectors. So choosing a particular value of b as far as OLS is concerned is, in other words, minimizing the distance between the fitted values and the error component. So अब इसको ideally आप कैसे समझ सकते हैं कि ये अगर मेरा actual y था, ये मेरा fitted value है. So this is your error term. So if I write this y, so I can write y as y hat plus e precisely because the fitted values here in this case is xb and the error term they lie at an angle of 90 degree with each other. And it is also your assumption that the error term or residuals, I should say residuals because we are talking about sample. So the residuals and the explanatory variables are uncorrelated with each other. And that's why you're precisely able to write them in this notation. And later on, in the next class when we discuss, goodness of fit and, decomposition of sum of squares, if we can easily imply the Pythagoras theorem over here, and you can write y, assuming this to be a hypotenuse, this to be perpendicular and this to be base, you can write them in the sum of squares form, which ultimately by some modification becomes nothing but your, what is called as r square. And then you simply say that r square is nothing but sum of two components. One is your explained sum of squares and another is your residual sum of squares, just giving you a simple hint that explained sum of squares will be obtained from this part, residual sum of squares will be obtained from this part. So r square is nothing but this component and this component. Not r square, that is total sum of squares, but r square को हम इसी way में समझते हैं. That r square is that proportion of total variation in y. So total sum of squares का वो proportion which is explained by your data matrix, which is explained by the explanatory variables that you have included in the model. It means r square must be defined like this. And this is precisely, you can easily derive this r square by just understanding this component. I'll stop here because I'll not load you up with many things in one go. But I just hope that, since now we have a 1 week time between our two lectures that we are supposed to have, it's an earnest request कि आप सारा चीजें रिवाइज कर लीजिएगा. और एक और बात कि प्लीज अगर आपने शुरुआत नहीं की है कोई भी सॉफ्टवेयर सीखने का, then please at least take one software, be it R, be it Excel, कोई भी हो, please आप at least start कर दीजिए. Just and because सीखने में time लगेगा आपको, and then once you learn any software, then trust me, you'll feel much more confident even while you step out of the institute as far as econometrics, statistics and other quantitative things are concerned. So there are many just एक data camp करके site है, आप उसमें free enroll कर सकते हैं. They have many number of courses. Otherwise अगर आपको खुद सीखना है तो there is this book which is Applied Econometrics with R. It's a very good book, and you can self-learn R by just referring to that book. And at least I'm sure that, I am not asking you to just be pro on R, but at least have some software knowledge, because in today's time, उसके बिना चीजें बहुत मुश्किल हो जाएंगी आपके CV में add करने के लिए. So, and whatever we have covered till now, please revise those things, because after this we'll move with solving questions either on Excel or on R. At least we'll take some data where we are able to apply these normal equations and find the values of B1, B2, B3 and so on and so forth. But those data, you understand that those data are either taken from textbook or are simulated data. But जब आप actually खुद की डेटा में या कभी आप अपना रिसर्च खुद से कैरी करोगे, आप परफॉर्म करोगे, you must be able to do those unknown calculations yourself. That is the purpose that I have as far as this course is concerned. So again an earnest request, please next class के पहले जितना भी चीजें हमने cover किया है, we have covered a very little portion as of now. Please revise all these before next class, that is on Monday. Okay, yeah.
So just a question.
हाँ जी.
So what is the limitation of the methodology that Gujarati uses?
I think as far as a student, I'll tell you. Hello, am I audible?
Yes,
Yes.
Karnataka.
Yes.
So as a student, I'll tell you that I did not find Gujarati textbook intuitive because the equations have been just written like that. They have not been, अच्छे से clearly उसको समझाया नहीं गया. That's why I don't personally prefer, not as a faculty I'm telling you, but as a student only. While I was reading Econometrics myself, I never found Gujarati textbook very intuitive in learning. उससे much better book है Christopher Woolridge, detailed textbook. It helps us understand with various examples, and it has been written in a very easy language. That's why I prefer that book. But again, whatever I'm saying need not be true for you. So जो भी आपको book लगे आप उस book से पढ़ सकते हैं.
Sir,
हाँ जी.
so not related to econometrics, but did you find our answer sheet?
I found, that's what I was talking to Srikant right now. Actually, I also have to finish your semester and paper by tomorrow, and I'm just too much. Anyway.
So, मतलब मिल गया ना my name can you उसकी
मिल
I
गया,
hope
मिल
it's
गया.
not somewhere in the mail because we still have copies.
No, don't worry for all this, sir.
Okay.
Yeah. No worries for all such kind of things.
Thank you, sir.
Okay. Any questions related to today's lecture?
Sir,
हाँ जी.
is it possible for us to see this in a three-dimensional space somewhere?
I'm really sorry, Ayushi, I do not have that software, but somehow if you can access any of the softwares which makes it possible to view, then you can easily see them, because these are equations ultimately which is of more than 2 dimension.
Sir, there are videos on YouTube which shows the visualization of data. So I think if you can randomly search on YouTube, I guess she can easily visualize the data, because I learned CLRM assumptions using that only, sir.
Okay. I'll see if there's actually there are lots of videos available on YouTube and other online sources, but somehow very few contents are actually good content. But so filtering out बहुत ही जरूरी है उसमें. But let me see, Ayushi, अगर कोई ऐसा वीडियो है या if through some friend I'm able to find a software which makes it possible, then definitely I'll go for that.
Sir, we can make it through Python, right?
Python में बन जाएगा, हाँ correct. R में भी बन जाएगा.
Yes, even Maxima we can do 3-dimensional space.
हाँ, तो अगर if any of you are able to do that, then well and good. We can have you present on that day. Present the content that you have. So कर सकते हैं, and that will be much more interesting once you actually because whatever we'll be doing, those are the things that actually software does. So अब जैसे बहुत सारे लोग ये सोचते हैं कि सॉफ्टवेयर कर ही रहा है तो मुझे पढ़ने की क्या जरूरत है, बट एक्चुअली सॉफ्टवेयर डज ओनली व्हाट इज बीइंग टोल्ड टू द सॉफ्टवेयर. जब एक्चुअल प्रॉब्लम होता है आपको, that's where your knowledge will come into picture ki हाँ ये test यहाँ पे करना था इसको ऐसे modify कर सकते हैं. That's why these things are necessary. Otherwise तो there is no need to even read econometrics at all, because almost all the things are being done on software these days.
So
हाँ जी.
could you also cover the topics of like the difference between the pool data and the panel data?
Yeah, data मुझे cover करना होगा anyway. Otherwise, what is the purpose of reading these techniques? We'll cover all this types of data, sources of data. We'll talk about all these types of variables. Scale variables, ratio variables, nominal variables, ordinal variables. ये सब हम cover करेंगे. Don't worry.
Thank you, sir.
एक और चीज जो मुझे आप लोगों को बोलनी है, बिकॉज आई थिंक none of the universities in India focus on this aspect, and they just completely ignore the topic of sampling. So I'll request ki take any good book. I'll suggest by next lecture if possible. But read sampling a lot, guys, because once you understand sampling, then whatever these are just techniques. Statistics use karo, econometrics use karo. We just simply teach sampling in just a matter of 4 or 5 hours. But sampling is a huge subject. It's a course in itself, which unfortunately our universities have not focused while teaching. Because once you understand sampling, then you'll not be dependent on any textbook for undertaking any exercises that you have. So अगर आपके पास टाइम हो, लेजर मतलब सैम्पलिंग बहुत जरूरी है इन सब चीजों को समझने का. Once you understand sampling, then trust me, lot many things will become so easy, so clearer in your head. I'm sure undergrad में भी sampling उतना पढ़ाते नहीं है, just stratified sampling, random sampling, snowball sampling, as if it is just a theory, and then people have written correct. Yeah, Neil, CMI had correct. So just read sampling, guys. जब भी आपको फुर्सत मिले, या एक habit बना लो कि sampling पे at least I'll read on sampling a lot, so that things are little bit easier. Because I'm sure that आपके statistics syllabus में I don't know कितना पढ़ाया गया sampling, but sampling is a huge topic, and it must be read by students if they are not taught, at least. That's a request. And why I keep telling you all this, because ultimately this is related to whatever we are doing, and I want you exactly to understand these concepts. Otherwise, marking in econometrics or solving papers in econometrics does not make any sense. So yeah, okay then, see you in the next class. But again, please, I'll request please पढ़ के आना, so that और भी interesting हो, और भी questions आप पूछ सको, चीजें और अच्छे समझ में आए. And till now I've been going slow, but I'm sure that you understand that with time I'll increase my pace, and in order to do that I want your help, and that is you coming prepared in the class, and then we can take the topics through a faster pace, so that we can cover a lot more important topics apart from OLS, because maximum likelihood बहुत ही कम पढ़ाई होता है. I'll devote time on that. Then violations में time जाएगा, simultaneous equation में time जाएगा, time series में time जाएगा. So let us just build our base in a quick manner, then we'll take this course ahead. Okay, all right. Thank you so much for being in the class, and see you on next Monday. Stay safe, guys. Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.